All right. Well, good morning, everyone, and welcome to our webinar today. I am Joe Pitera, the Sales and Engineering Manager at Access New Jersey. First, our thoughts and prayers go out to all who have been affected by the virus and current events that are affecting all of us. We want to extend our sincere appreciation to all of the frontline workers, essential suppliers, and those supporting them. If we work together, we can make this world a better place. I want to personally thank all of you for taking the time today to attend this presentation. It is going to be a live webinar. I actually have shown on the screen here the demo equipment I have set up in my office right now, which has a Siemens drive system, Siemens HMI, Siemens PLC, and that over there in the corner is an Allen Bradley PLC as well, talking all through a Siemens switch. I see some people have joined us here, so let me let them into our webinar here. Good morning and welcome. So as we put that off to the side here, we will learn more about Siemens EtherNet IP capabilities in a moment, but first a little bit about Access New Jersey. If you work at or maintain a hospital, university, transit, airport, water, wastewater facility, building, commercial or apartment style, you may need electrical, plumbing, HVAC, building automation, etc. If you work in industrial processes, manufacturing, or making the machines, you may need electrical, plumbing, controls, automation, and even robots. We can help. Acquired in 2015, Access New Jersey is part of a group of companies under the PowerFlow Technologies umbrella. Together, we are 14 companies strong and growing. These companies provide you the supplies, services, and solutions needed for your business. As a high-tech distributor, we specialize in automation, control products, machine vision, machine safety, data acquisition, drives, motion control, and yes, robots. Our staff of engineers and specialists are available to assist you with projects of any scale. The PowerFlow engineers and specialists are available to easily cover the entire Northeast. Access has been helping businesses in Metro New York and New Jersey area for over 30 years. We can provide the full range of value-added services to commission your system, train your staff, and minimize downtime to achieve the lowest total cost of ownership throughout the entire automation lifecycle. Siemens and Rockwell products working together? Yes. That is true, we can do that. Today's agenda: why does Ethernet IP connectivity matter? Siemens portfolio for Ethernet IP connectivity and how seamlessly connected Ethernet IP networks. I will have the hands-on lab here live, commissioning a G120 drive and connecting it via Profinet to a Siemens PLC. And then with one parameter change in the drive, I can talk to a Rockwell controller as well. Our HMI can support talking to both the Profinet and Ethernet IP simultaneously. Why does Ethernet IP connectivity matter? Here is a chart showing the global market share of Ethernet-based protocols. Ethernet IP protocol and Profinet are the most popular. Ethernet IP is an industrial network protocol that adapts the Common Industrial Protocol, CIP, to a standard Ethernet. CIP is a media independent protocol using a producer-consumer communication model and is strictly object-oriented protocol at the upper layers. Profinet is an industrial technical standard for data communication over industrial Ethernet, designed for collecting data from and controlling equipment in industrial systems with particular strength in delivering data under tight time constraints. I will have links following this webinar to both the Profinet and ODVA websites. Looking at the industrial Ethernet market, globally speaking, Ethernet IP and Profinet have virtually equal market share. In the US, Ethernet IP has a larger installed base than Profinet does, almost 2.5 times. But in recent years, Profinet has increased their bases here in the United States by 21.6% growth. Customers do not necessarily choose Ethernet IP over Profinet. However, when they standardize on Rockwell PLCs, the Ethernet IP network becomes the de facto interface. Siemens products talk both protocols with the same unit. This is what customers should care about in this workshop. One hardware configuration, just swap out the PLC to cover most of your needs. Upstream and downstream communications without limitations to specific network types would be important when configuring your systems here. We can have one drive controller, one HMI, one remote I/O, and several other Ethernet IP products that can easily connect with all the network connectivity to reduce costs and give you the most flexibility in your automation system. Both Profinet and Ethernet IP use the physical layer of the plant's industrial Ethernet to communicate with their protocols. This can be compared to using the same phone line to speak different languages. The key is having the application layer to understand the language protocol being spoken. Why is Profinet the Ethernet standard for automation for most of the world? Open standard. Profinet is a multi-vendor technology managed by Profibus Profinet International. Most complete industrial Ethernet protocol addresses discrete process, motion, safety, and wireless applications. It coexists with standard TCP/IP traffic and minimizes network traffic without the need for special switches. You can achieve a flexible architecture, line, star, tree, ring, wireless, Cat3 safety functions over wireless as well. And you have a high performance 1 millisecond cycle time for standard applications. Cycle times less than 1 millisecond are possible in motion applications. And we have additional guests. Siemens has a comprehensive line of products with flexibility to communicate with Rockwell controllers and integrate into the Ethernet IP networks. From networking switches and switches, distributed I/O, HMI hardware and software, RFID drives to cabling, Siemens can communicate with the entire system. We will demonstrate this during the first part of today's webinar. Our products communicate with Rockwell ControlLogix PLC over Ethernet IP protocol. This product is unique to the market. With the ability to add starters to the rack, full voltage non-reversing, full voltage reversing soft starters, and its compact footprint and distributed power module, the SIMATIC distributor I/O can be connected both Profinet or Ethernet IP to different controllers. This benefits in minimum downtime, smaller footprint, and substantial cost reduction in both engineering and commissioning. Siemens has the broadest portfolio in the marketplace for HMI and HMI panel technology. Mobile versions have tethered connections, connect to one device, unplug and connect to another. There are wireless options as well. All HMIs talk both Profinet and EtherNet IP. The same product can be used for the number 1 and number 2 PLCs in the world. Comfort panels have two ports, a 2-port switch built into it. A 1-port switch so you can have a linear topology, and yes, still having a separate LAN for a supervisory connection. There is a tag migration tool which allows RS Logic's tags to be easily imported into WinCC engineering software. There is a demo available which we can share with students later on after this webinar. If you use RFID technology, the RFID readers are also Ethernet IP compatible. Some of the application requirements for using these products could be abnormal temperatures, speed of reading, reading write access, read only. Siemens also has networking infrastructure products for the networks, whether it's wireless, managed, unmanaged switches, and even radio. Scalence LAN, W for wireless products, S for switched wired products. We have a broad range of products, high-end, mid, and low-end, wireless products and antennas, different types of medias for copper, fiber optics, or even glass fiber. Products for both access points and clients. Rapid roaming technology developed by Siemens has a deterministic wireless, guarantees the PLC will be reading the IOs without tripping the processor. There is a 32 millisecond guaranteed update, 16 milliseconds also possible, and that is increasing with the next revision coming out. We can go up to 3.8 megahertz with rugged COM products and 2.4 megahertz on our standard products. This example for this slide shows the automotive industry, the Disney Toy Story ride. The wireless device had one antenna removed and a resistor put in place. The other antennas were also removed and a leaky coax cable was put in place. By doing this, the customer was able to eliminate the wired devices and brushes that had demanded constant maintenance. A little animated picture here. Whether this would be carts for productions, cranes, or autonomous mobile robots. Siemens offers industrial cabling as well. Siemens cables are not required for any application. Customers can choose your own cables, obviously. Siemens has stripping tools that cut the conductors and shield to the right length so that when you're using our connectors, customers will have an easy and reliable cable connection. Our RJ45 connector is metallic, not plastic, to maintain the ground and shield connections entirely, which is important in systems using servo controls or high noise areas. It connects to the switch frame, not the PC board, assuring better shock and vibration resistance and not damaging the PC board. Field bus was invented to reduce the amount of wiring. Big, large cable runs back to the main PLC. Line topology is less expensive. No need for performance. Customer is only worried about the amount of wiring costs. With utilizing the Siemens products with the 2-port switches built into all of our products, we can create a line topology without the necessary additional cost of a switch. A start topology guarantees that if one device goes down, like hit by a forklift or damaged in some way, everything else will continue to operate normally. This is a mean to, everybody can do it. It requires only 1 port per device. The drawback is that you are putting all eggs in one basket and having to wire everything back to the main controller as well again. Ring topology is used for high availability redundancy. If one device goes down, the others will continue to operate normally. It requires 2 EtherNet ports per device. It also requires the PLC to have a redundancy manager capability. Both Siemens and Rockwell PLCs have it. Most of Rockwell PLCs don't have a 2 Ethernet port, so ring topology is only possible with the addition of a switch. But Rockwell has recently introduced a new series of PLCs in the L3 series that do support ring topologies with built-in switch. One of the major goals of this workshop is to show Siemens their preferred VFDs options. G120 is the bread and butter product mainstream drive. Starter is a commissioning and programming software for the entire family. Start Drive currently has is integrated into the TIA portal and supports many different product families at this point as of version V16. Using the S120 family, we can address any high performance, high demand applications as well with less than 1 microsecond scan time. This is only supported on Profinet, isochronous Profinet. So here we're going to try and explain having the entire drives family under the same platform. The parameters are the same for the basic drives to the high-end drives. If you learn one model, you know them all. The parameters are grouped in blocks, so the basic control units will not have all the parameters. As you move towards the high-end drive control units, new groups of parameters are introduced while maintaining the same basic ones. The Sinamics V is a commodity drive shaft turner. Only serial communications, Modbus RTU, and USS are supported. It's a great low-value drive to get just the simple applications running. The next product group is the Sinamics G converters and inverters for single-axis applications. They offer more efficient solutions through optimization to meet your needs. The Sinamics S series is for high-performance multi-axis applications. The G120 is a modular inverter, more flexible, safe, and efficient. It consists of a power module, or the muscle, a control unit, or the brain, and an operator panel, or the eyes. The Sinamics G120 modular system, the inverter can be assembled to match the needs of your machine. You can choose between a control unit for basic applications with safety functions or with positioning control. That way, expanding your machine is easier. The same power unit can have different control units simply clip on and wire in. In case if there's a failure of the power unit, you can simply unclip the control unit, replace the power unit, wire in the three-phase power in and the motor out, clip on the control unit without even having to remove all the wires to it, power up the system, and you'll be back and running in no time. No need to even download parameters because the parameters stay in the control units themselves. If an old power module is not working, the module can be replaced quickly with the new one. The inverter will operate with the old control unit with no need for commissioning. For example, Pepsi Company bought equipment from Europe which are not suitable for the type of power grids in the US. They blew some power modules on the production floor as a consequence of the incorrect power units selected. Siemens was able to ship replacement units overnight, have the damaged power modules replaced in 45 minutes. No need to change the control units, nor download the program or commissioning the drive. The production was up and running by the next morning. Customers can use any memory card for parameter savings as well. So you can easily commission additional drives without the need to download starter or commission through the IOP. When a user inserts the memory card to copy the parameters, everything is copied except the communication parameters. So if you have multiple drives in a lineup for, say, a conveyor belt, you could just commission one drive, copy the parameters to a memory card, and then put the memory card in a second drive, let it boot up, and it will automatically read all the parameters and commission the drive without even connecting to it. Here is a slide showing the modular eyes, brains, and muscles. They have two different type of eyes here. The BOP, which is the basic operator panel, just standard display for commissioning and diagnostics. The intelligent operating panel, the IOP, has intuitive menu guidance with application wizards and graphics also built in. There is a handheld version of this as well, so you could not have it always plugged onto the drive and just use it as necessary. Here we're showing 4 different control units. The control unit 230P-2 for pumps, fans, and compressors. The B for basic, general machinery. There's an E for basic I/O and safety. There's the S, which has EPOS positioning and extended safety functions as well. There is a PM240-2, which comes 230 volt single and 3-phase, and then 3-phase 480 volt. The same power module here is shown for both the G120 and the S120 versions. There is a PM250, which has a regenerative capabilities back to the grid as well. A unique feature in the power module with regenerative feedback is in a module without regenerative feedback, braking resistors are normally used in case of energy generation on braking or emergency stops. Energy would be dissipated as heat in the resistor. However, when using a module with regeneration, the energy is returned to the power grid. That way you can save on energy, the resistor space, and you can reduce panel temperature. Most other vendors do not offer an integrated regenerative solution. Another advantage of the Sinamics G120 is provided by the integrated safety functions. Before safety integrated, safety functions required many external components such as safety relays and contactors, dual braking circuits. With the safety functions integrated into the inverter, the functions of the e-stops can be wired directly to the inverter. The functions are certified under SIL 2. You save on components and, as a result, on space and costs. In addition, if you combine a PLC that has safety functions, you can send the e-stop signal directly from the PLC to the drive via Profinet, what we call ProfiSafe network. Be it detecting, evaluating, or reacting, with our safety integrated products portfolio, we cover all safety tasks in the production industry. Completely verified safety technology from one source that is integrated and consistent in the sense of totally integrated automation. For you, this means safe, reliable, and cost-effective operation. With our products and systems for standard and safety technology and relevant services and training from one source, you can be sure Safety Integrated always offers a fast and, above all, cost-effective solution. Regardless of whether you decide in favor of conventional bus-based or control or drive-based solution, you have a degree of flexibility here, and or whether a simple emergency stop function or a simple safety circuit or high dynamic events degree of safety capabilities. Enhanced diagnostics. This is one of the best keypads on the market currently. One of the cool features of its ability is to offer visual status and assignment of each I/O. This is handy when troubleshooting an application after it's being installed. For example, what is wired to analog input 1? What does digital input 3 is set for what? All right, so we're going to go over here to a hands-on lab here, which we're going to, I don't hear the audio on this. Quick little video here on Sinamics drives. So a little bit about our setup here in our office, in my office. We have a S7 1500 PLC. I'm going to try and expand here in our window. We have a Scalance EtherNet rack. We are connected to a Siemens 1500 comfort panel, TP 1500. We are connected to a G120 drive here on the left. And I also have a Rockwell PLC, which is currently not connected, but configured. So let's try and There are Siemens videos and manuals available for the below configurations and steps on how to integrate the add-on instructions. We're not a Rockwell experts here, but from my experience, there is an add-on block here that we can simply drop in and set up the address range, and it will talk to the Siemens PLCs. Add-on instructions are designed to mimic the Siemens standard telegrams. Free telegrams can also be selected in a Sinamics drive if the user does not want to use the canned solutions. Siemens has videos as well to help set that up. I will send that as a link as well in the follow-up emails here. Here we're showing the different telegram structures that are available, which are the standard telegram here with the status word and a control word, the actual speed and speed set points. Using a telegram 20, we can get some additional feedback from the drive back to the PLC and just given a status control word and a speed set point. If your applications are more complicated, we can set up some torque limits and get some additional feedback. Here we can get alarm codes and fault codes as well. So the hands-on lab, we will commission the G120 drive. We will have it talking to the 1500 via the HMI. And then I will flip a bit and have it plug in the control logics and have the HMI talking to the control logics and the control logics talking Ethernet IP to the drive. Being that this lab is being run on a webinar now and is kind of reduced in time, by showing that the same drive can switch from Profinet to Ethernet IP, I should be able to kind of prove out that you can run both networks at the same time here. Okay, so moving forward. Let me set up my lab. So here is starter software. It is a freeware, can be downloaded. The latest version is version 5.11. That can easily be downloaded off of the Siemens Industry Online Support website. When you open up Starter, it kind of gives you a blank screen here. Might have a help window or a wizard to help you get commissioning. I'm just going to start with a brand new project here. I am going to call it my EtherNet IP webinar. As it creates the project, there is an icon over here that has kind of an exclamation point that we will use to identify what is on my network. Now I have a Ethernet cord plugged in from my PG here, my computer, to the switch, and on the switch there's a wire going to the HMI, a wire going to the PLC, and a wire going over here to the drive system. And you can see in the picture that the wire currently to the Rockwell controller has been disconnected. When I click on this icon here, it searches for accessible nodes. This does a MAC level search for accessible nodes out there and asks to get some status back as to what is your Ethernet IP address, And what is your Profinet name? And it's still searching. And of course it did not. Let's try and update that. And we have some additional guests coming in. Okay, so we have found this bus node with a illegal IP address of 0.0.0. It is a Sinamics G120 CUT40. If you right click on that and edit the Ethernet nodes, we are going to give this an IP address. And for my demonstration here, I am going to give it the IP address of 192.168.0.11. And it is going to have the standard subnet masks of 255, 255, 255.0. I am going to assign the IP configuration to the drive. It told me it was transferred successfully. And I am going to call this drive 1 in my project. And I am going to assign a name to it as well. And this was happy. So I'm going to update the list now to see if those IP addresses and the name was sent to the drive. Now that it actually has a name and a real IP address, it can get some additional information for communications. This gave us a little checkbox here that we can attach, and we can accept it to my project here. This is actually allowing the software to go out and gather the control unit and bring it into my project here. At this point, we can go online with that drive unit, and we will see that the offline has not configured, but the online knows there's a PM240-2 attached to this. We are going to load the hardware configuration to my PG at this point. Now it knows it has a full drive system here. I can just upload everything to my drive to make sure I have everything uploaded. And we are now up to speed here. So I am going to save this. I am going to go offline, and I am going to go to my configuration here. You will notice that in the control unit configuration, there is a nice yellow button here called Wizard, which is going to take us through a standard pop-up configuration wizard. So in this case, we are going to use standard drive controls. You have some choice here for some dynamic drive control. I will the standard drive control will default the control method to use volts per hertz, whereas the dynamic drive control will use a sensorless speed control open loop vector control. For this case, we're going to try and use maybe expert. So in this case, we now have a choice of how do we want to set up the drive system here. We will try and do this one speed control encoderless or sensorless vector mode. We will use no changes for the set point command sources. The default for the control unit is field bus with dataset changeover. So we are going to continue using this because we are using a PLC to control here. We are going to select a NEMA 60 Hertz SI units. We are going to use a 230 volt supply voltage here for our drive. And we have the overload capacity will be a low duty cycle with low overload for vector drives. You have your choice here with high overload. We have an S1 and an S6 duty cycle for internal uses. So in this case, we don't have a lot of overload on my demo unit. We are connected to an induction motor. And our motor is connected in a star. It is rated at 230 volts. The motor rated current is 0.73 amps. It is a 0.12 kilowatt motor. It is rated for 60 hertz. It is rated for 1650 RPMs. And we have the cooling type is naturally ventilated. Over here you could have forced cooling if you had an external fan. If it was liquid cooling by some external liquid cooling, or if there is a totally enclosed non-ventilated type motor, you would pick the final one there in the selection. We are going to change the ramp times for our demo here to 3 seconds. And we are going to leave the max speed at 1800 RPMs. And we are going to take the off 3 time to 1 second. Off 3 is the fast stop or quick stop time ramp when you want to use a off 3 command. We are going to say this is just a standard drive, but we want to do a motor identification to make sure that we identify the motor's magnetizing current, the resistance of the cables, and the motor induction as iron core as well for all to make sure the motor is identified by the drive for tuning. We are going to identify the motor at standstill. Here is the selection we're going to utilize. We are going to do a complete calculation of all the parameters based on the information we supplied. Here's some commissioning notes that we can put into a manual for a startup or a service report. So you could copy this to the clipboard and put that in as well. All right, so the next thing we are going to want to do is on the communications here. We are going to go to the field bus. And we are going to connect, we are going to use Profinet on our first programming here because we are originally connected to the Siemens PLC. And we are going to set up the telegram 352. And 352 is essentially what we showed earlier today, which gives us some additional find writables to the drive as well. What these could be is different gains. We could set it up as upper torque limit, lower torque limit, and other dynamic variables that could be sent to the PLC. Receive direction, no Profi save, 352.66, okay. So at this point, we're going to save this project. We are going to go online with the drive. And I am going to just use this big yellow download arrow here, which says download the project to the target system. It's going to give me a pop-up box here that says it's going to copy everything from RAM to ROM. And it's loading our program. And let's see, the drive is actually went from a faulted position to something that is almost booted up. And we are seeing some errors. As the loading is almost done. Okay. So as we downloaded all the parameters and cycled power, the system is coming back up online. So the first part that we are going to do here is a motor ID at standstill. So you will hear the drive cooling fan come on. The shaft might rotate a quarter turn or less. You will hear a series of high frequency rings from the motor while the motor data ID is in progress. And upon completing the motor ID, the drive will stop running and return to a ready state. We can either use the hand mode. I'm going to try and show this here. On the IOP, there is a hand mode we can use on the drive itself. And you can see that the motor ID active is currently set up on the IOP. But since this isn't so easy to see from remotely, we're going to try and just take control of it from our software here. On their commissioning control panel. At this point, a pop-up window shown on the bottom here, has a few tabs. The one tab here is for alarms. The current alarm is a warning that the drive motor data identification is activated. We are going to assume control priority here, which gives us a little pop-up window saying that you are taking control of the application, so please be safe and make sure nobody gets hurt. This gives control now to my laptop, where I'm going to give it the enables, which now allows me to start the drive and give it an RPM. We do know that it's going to do a motor identification, so do not enter any motor RPM set point. Oh, by the way, if you don't see all of these additional information here, it could be because this button for additional diagnostics is not there. There is another button here for further diagnostics, which tells you which bits are missing. They'll give you the speed set point, the speed actual, the torque set point, torque actual, and we can see some predefined or selectable variables here as well. If they want to actually show this window bigger, drag it up to make the window bigger. So for the motor ID, you can see the green light came on the motor. It is the display turned green. It is going through its motor ID process. It did go through its humming and noises. It just shut off. So it's now ready for operation again. And what I can do now is enable it and give it all, and you see all enables are available, and we can give it an 100 RPMs set point. You actually see that it is operating here. I do have a little bit of a brake action on it. And I don't know if you can see that, but I put a rubber band on a leather brake that's around the output of the shaft there, so it is causing a pulsating type of load on this. I don't know if you can see that, if it's updating fast enough on the screens. Probably not, due to video refresh rates. But we can actually monitor the load there as well. All right, so that was pretty easy to commission the drive and get it running. We can see that there is some green lights on it as well for Profinet communications. And what I'm going to do now is stop the drive. And we actually finished commissioning this drive, so congratulations on that. I can show that by giving up the control priority here. I am back in manual mode here, and I can select hand control, start the drive. And I am able to as well run the drive from the local IOP panel. This kind of has the feel of the old iPods. And since this was already pre-configured to run Profinet, I should be able to start the drive from the HMI, give it a speed set point, and zoom in to the screen here. And you should be able to hopefully see that the system is running. It's showing the motor amps, motor torque, and the motor actual speed. Although the clarity isn't the greatest, I apologize. And if I stole this out, you can see that it has a speed deviation alarm popped up immediately. And if I hold it tighter even longer, and I'm going to get it to fault out. But we are getting additional data from the drive right to the HMI through a standard telegram and a standard block inside the PLC. I can stop the drive from there. Okay, so now we showed that we were able to commission the drive and run it from the Siemens PLC relatively quickly. Our next objective here is going to be selecting the drive to run on Profinet instead. So by going to the expert list here, you can do this through the IOP as well, or we can go to the field bus and change this from Profinet to EtherNet IP, or we can go to the expert list and I'll show you the actual parameter here that needs to be converted. By typing in the parameter quickly, you can go right to the parameter. So in this case, it's parameter 2030. I mistyped it, 2030. Here it's selected for Profinet. I'm going to drop down the box and go to Ethernet IP. Here it gives you a pop-up saying that the value does not take effect immediately. The activation rules are described in the online help. This usually only happens after a power cycle. So we are going to copy RAM to ROM onto the drive unit, copy RAM to ROM. I'm going to save the project. And there is a trick here, so I'm going to teach you this trick here. By going to parameter 972, you could do a drive unit reset, which is really a reboot without cycling the power. So we're going to go to a hardware reset immediate here, and this is a software reboot for the system. Of course, you could go and disconnect the power on the whole drive cabinet, but if you have a bunch of drives and PLCs and other things, you may not want to cycle power that often. So as this thing is rebooting itself, we now have a fault on the communications on my drive. I am going to disconnect the Siemens PLC and connect the Rockwell PLC. I'm going to go to the EtherNet IP screen, and you can see that the that the drive is now happy and ready to communicate. I am going to hit the run, and it is now communicating Ethernet IP to the Rockwell PLC to the Siemens drive. And we can change the speed set points. And we see that we can get the alarms as well coming out of the drive into the over Ethernet IP. So one drive, you select the PLC. It makes it that easy. There is a lot more we can go over. I wish this was more of a hands-on approach. We will be opening up our doors for practicing social distancing and a maximum of only 6 seats in our training facility moving forward. That more to come in the next few weeks. I am actually way ahead of time on this, showing our capabilities here. I do appreciate everybody's time. And we've completed the hands-on lab at this point. If you want or have any questions or want to be able to have a live demo or work on one of these or any kind of a sizing, let us know. We are here to help. At this point, let's see, slideshow. I'm going to say thank you for your time today. Give us a holler if you need anything. Does anybody have any questions? Feel free to unmute yourself and let me know.
Hello.
Hello.
My name is Brandon. I work at Novotics.
Hi, Brandon.
Hello. I was wondering if I can have a recorded session of this.
I did press the record button. I do believe it was recording. I will share the entire slide deck and a few links here as soon as I can put them onto a SharePoint site. And I will send that link out to everyone that was registered.
Wonderful. Thank you.
Not a problem. And if you have any questions or you actually have a project that you need assistance with, please feel free to give us a shout out here at Axis. We're here to help you. I do see some chats here. Yes, we got that. I got your chat. All of this information will be given shortly as soon as I can set it up. If that's it, I'm going to say thank you, everyone. Please have a great day. Stay safe. We'll see you soon.